Welcome to this video. We will continue our discussion on chapter 13 Microsimulation. This is probably one of the most important video of entire TSAP series because today we are going to the most anticipated cluster analysis. Like I have been saying in previous video, which has massive implication on time and budget. And we will also look at FHWA guidelines as a part of this manual, but some of the important part of manual of 2019, which has been out for 4 years but not being used as much as it probably was intended to. So we will see what are the key components of FHWA guidelines. We will discuss the calibration in future video. However, FHWA guideline has been out for 4 years, but there has been very limited use. So from my personal perspective, because of the cluster analysis, once this guideline came out, FHWA 2019 guideline, everybody was excited to read through it, but then a lot of us felt that this is not a practical guideline because of the requirements of data, because of the heavy data requirement, and it requires a large budget. We felt that this will probably not be a practical. Large budget requirements, we thought that is not practical, but now is kind of recommended in TSAP, and also it is required for IIJR. So it will be very interesting to see how things plays out. But we will discuss today what are these requirements, why it's causing a lot of concern in the industry, and basically why it has not been so much used as it was intended to be from the beginning. So it's been out for 4 years but not really being used, and some of the reasons why it's not being used. So first we'll look at what is this guideline, which is FHWA Traffic Analysis Toolbox Volume 3 Guideline for Applying Traffic Microsimulation Modeling Software 2019 update. What is this guideline? What are some key things which are in these guidelines, and some of the reasons that makes it very difficult to be used in practice. So welcome to probably the most influential change in the guideline, which is FHWA 2019. This changes the way we traditionally do traffic operations. So FHWA 2019 guideline changes traditional traffic operations. So before moving forward, the fundamental difference between 2014 guideline or 2004 guideline or traditional way of doing things is we design our roadway for a typical day. Whereas as compared to 2019 guidelines, at a fundamental level, 2019 guideline says is not every day is a typical day. So we need to look at the trip reliability by analyzing different days. So we need to analyze our system under different conditions. So let's say condition 1, let's say is bad weather. Then let's say we are analyzing under good weather. Then let's say we are analyzing under incidents. Let's say we are analyzing under work zones, etc. So what 2019 guideline says is not every day is gonna be a typical day. So in order for us to design a reliable system, we need to look at other conditions and group them, and based on the probability of them happening, let's say most of the year is good weather, then based on FHWA 2019 guideline, a lot of our results will tend towards the good year analysis. So this is called reliability analysis, which works on probability of different clusters happening. So we have different clusters, we have different conditions, let's say scenarios. Based on probability of that incident or that scenario actually occurring in real life, then we can calculate what is the probability. Let's say this is a scenario where there is a lot of congestion. So what is the probability that there will be incident and there will be congestion due to them, and then we can design our system based on those probability. So this is a reliability approach from FHWA in 2019. However, the data requirements for this approach and the model building is so extensive that it has been not used as much. It has very limited practical use so far. So since the guidance came out in 2019, all of us have carefully read and watched FHWA videos, and there has been a lot of doubts in transportation in industry, or a lot of engineers like myself, on whether this is ever gonna be practical or not. So today we will look at some of the key things about 2019 guidelines and see why it has caused such a major concern in the industry or among the engineers. So without more discussion, let's get into FHWA 2019 guidelines. So to follow the 2019 guidelines, data collection sources are in addition to regular data collection, we need some permanent count location data to calculate demand or volume for 365 days. Origin destination based data for I'm not sure what the use of this one will be, but if it's for cluster analysis, then we will need it for 365 days. But if it's for dynamic traffic assignment and model setup, then we will need it for representative day. And we will look at what representative day means very soon. Then we need 365 days of weather data. We can get weather data from National Weather Service or similar sources of data for precipitation, wind speed, snow, visibility, etc. Then we need 365 days of data for incident and other data sets if we need. For bottleneck throughput, if we are going to use bottleneck throughput as a part of defining travel pattern for cluster analysis, then we need 365 days of data. And if we are using for representative day, then we will be using representative day. Then we need travel time for 365 days. FHWA recommends collecting a year worth of data to perform cluster analysis, which is 365 days I have been talking. Collect at least 100 days of data from different sources such as STARS2, Traffic Management Center, and travel time from other data sources like INRIX. Standard analysis data. As per FHWA guidelines, to mirror the real-world conditions, models are typically calibrated to data collected on a single day. So traditionally, we have been collecting 2 days of data and averaging them out to average day. So let's say we collect the traffic data on, this is my Tuesday, and then let's say we collect another data on Wednesday for the same location. Then traditionally for past 20-25 years, what we have been doing is averaging them out to come up with a curve like this. However, when multiple days of data are collected, most representative day is typically selected and replicated in the model. So the new guideline is to select one representative day out of many days of data we have. So we have, let's say, 365 days of data. Instead of averaging few of the days, we choose one of the typical days, and there are some advantages of choosing a representative day compared to averaging them out, which has been described pretty soon. So cluster analysis group similar object into respective category using a statistical method, which is described in FHWA 2019 guidance. We can set up Excel, we can do it in R and many other software. It's really not that something to be discussed too much. It can be easily done in Excel, which just by following the guidance which is provided, or we can do in ArcGIS or many other software. Cluster analysis determines the pattern of association by grouping object together. For example, let's say for group 1 we have medium demand with high precipitation. For group 2 we have high demand with clear weather, which is the typical day we typically collect. Then sometime we may have high demand, clear weather, but there are accidents on the road and there the travel time is high. So these are different group of data points. So let's say this is this cluster, this is this cluster, this is this cluster, and this data point is like travel time, bottleneck throughput, and other things. So instead of just looking at typical day, now we are looking at different scenarios and trying to design our system such that it fits all the scenarios. So cluster analysis in microsimulation develop multiple cluster that outlines different type of travel conditions, erode user my experience, and the examples are here. For cluster analysis, data from multiple sources is used to establish relationship between different data type and determine different travel conditions. Therefore, FHWA recommends collecting up to years worth of data. FHWA 2019 guidelines includes a step-by-step process on how to perform cluster analysis. Like I mentioned, we will look in one of our video on those steps, but for now it's kind of we will leave it as like if you open the FHWA 2019 guideline, which I personally have many times. There are step-by-step analysis of which you can set it up in Excel to perform this cluster analysis. Perform a representative day analysis for one cluster and meet the calibration criteria for that. So representative day analysis for one cluster, this is a very important statement. So in this example we have 1 2 3 4 5 6 clusters. In this example we have 6 clusters. Now from 6 cluster we will choose one representative day each. One representative day each, and we will end up with 6 representative day, one for each cluster. So for example, for this cluster it may be this one, this cluster it may be some, let's say this one, this cluster, this one, this one, this one, this one. Now these red circles are representative day, which I have written here. So instead of building our WISM model typically for one average day, AM and PM, what I believe is now we have to build our WISM model for 6 clusters, AM and PM, which I believe will be very challenging. Another big challenge would be to use these clusters. For example, if I'm right now, today's date is March 6th 2023, so I am in March 2023. Let's say I want to perform a cluster analysis, then I will go and look back the data for 2022. So I went back in past, got my volume data, got my travel time data, got my weather data, got my incident data, got my work zone data, and all other things that we can think of. Now out of this, let's assume I have created this cluster which is here. So let's assume this is the result I came up with, which is average bottleneck duration versus average travel time, and I came up with 6 clusters. And now let's say this one occurred on March 01, this one occurred on August 13th, let's say this one occurred on April 15, and so on. Now to simulate this number, this particular day, I need the data from August 13 to see what has happened on August 13. Now what happens is, for this cluster analysis, we can use the volume at some location for 365 days, but we know that when we are working on a freeway project, so let's say this is my freeway with bunch of ramps and turning intersections, we know that we need the data for each ramp and each turning moment count. So we need interchange data for 15-minute interval, we need ramp counts, and what we are doing cluster analysis is based on one location. That's it. So one location here, maybe 10 miles away there is another location. That's the only locations where we can get 365 days of data. So cluster analysis needs 365 days of data, which we can get from permanent location counts, so here and here, but we don't have August 13 data for these ramps or this intersection or this ramp or this intersection. Pretty much 99% of project we do not have any data for August 13. We don't have data for April 15. We don't have data for March let's say March 1st. We don't have 99% of data needed to build the microsimulation model. Now we cannot go back in past and collect this data. Go back in past and recollect this data. What we can also not do is use big data sources, because those are sample based data. As of now, low accuracy data, low accuracy volume data. So I am not exactly sure, once we define the cluster, how are we going to collect all this data. Let's say this one came out to be September 2022. Are we going to wait till September? Let's say this is September 1st, September 1, 2022. Are we going to wait till September 2023 to collect this data? What if this was Monday and this is now Sunday? So cluster analysis is a good concept if you have 365 days of data for all the locations. However, in practice we barely can get one single location near the project. So it still needs to be seen that how exactly we are going to use this cluster analysis. It's easy to do the cluster analysis. It's not at all easy to figure out how to use it unless we have the data, because of the data limitations. If we have unlimited data of every locations and every day, we can simply follow the guidelines. This is the main reason, in my personal opinion, FHWA 2019 guidance was not in use so far. So this is the major limitations I felt for last 4 years that limits the use of FHWA 2019 guidelines, and we still have to see how things plays out with this new TSAP manual. So selecting a representative day is pretty easy. We draw within the cluster, we take the average of the cluster and see the distance of each point to the average, and figure out a point which is closest to the average. So choose the choose the day which is closest to the average within the cluster, and that becomes our representative day. So it is important to calibrate to a single observed representative day rather than average of multiple days. An average of multiple days could create an unrealistic performance measure, which I just described a little bit ahead up, that we typically used to do average, and it flattens the curve. So let's say there is a sharp increase in one day, and another day that sharp increase is a little bit ahead. So if the sharp increase is not overlapping, then it would end up flattening the curve a little bit. So taking the average kind of takes out the edge, which is now captured by using representative day, which is a good improvement. Additionally, averaging creates the impression of weak bottleneck, which is the sharpness, with inconsistent time-dependent flow rates. To select the representative day from the travel conditions, key performance measures used in cluster analysis are average 15-minute interval. It is recommended that the day with the closest value to the average value should be used. I believe this is a typing mistake. So this word, I believe, needs to be used. This is just a typing mistake, I believe. The process of selecting representative day is typically completed using a cluster analysis, which helps account for variation in data. This for additional guidance on how to complete a cluster analysis. We will look at how to perform a cluster analysis using FHWA approach, which has been given, or different toolboxes which are available.